Cool. So a bit about me. I'm a computer science graduate of class 2016, and like Shank introduced me, I'm currently working as a senior full stack engineer at Harness. So Harness is one of the continuous deployment automation leaders in the industry right now. And I have around 4 years of experience into modern full stack web development. So what that exactly entails, I'll let you know in a bit. And you can add me on LinkedIn. My ID is Vardan Bansal. That was a bit about me, and let's dive right into it. So, I guess a lot of you would have done your engineering internship, or if you are in the session, probably you are interested in software engineering. So you might be having a vague idea of how a modern web app looks like. So when somebody talks about LinkedIn or Facebook or Instagram, so these web applications, just to put it in very simple terms, they have two major aspects of it. So there is a client and then there is a server. So client is what is a way that you can interact with the server. And server is essentially what powers your client. So whatever data that you see on the client is essentially being provided by a web server. So a web server, so if you see clearly, the lower half of the picture is essentially called the backend of your application. And that backend might constitute a web server, an app server, a database where you might eventually store all your data, and there could be some static assets like CDNs and distribution networks. So this is, if you put it very simple, this is how a web app looks like. So a lot of us, when we graduate from a college, we do have experience working into languages like C++, Java, like it depends on Python, it depends on somebody's interest. But from my experience, what I felt over the period of 4 years working in the industry is a lot of us have a tendency to directly jump into backend development. So backend development, if you see, is the part where you write some code to provide data so that your client can consume. So, for example, if you talk about Facebook, all your friend list, all your feed that comes up on your timeline or your friend list, all of this comes from a web server. So we have a tendency of, and I've seen like even our recruitments, most of the companies have their profiles, all of their interview rounds focused mostly towards backend development. So front-end development is an aspect we don't really get to tackle in the interviews. And as a result of that, a lot of us don't have any exposure into what also front-end development means. So when I started as a back-end engineer, and luckily I had an opportunity to work on the front-end side of it as well. So that is where I got introduced to this fancy term of full stack engineering. So if you talk about who exactly is a full stack engineer, so the wiki definition is he is an individual responsible for engineering the end-to-end features of a system. From initial experience, it looks like he has to code the user experience, the client side also, and also the backend, which will power his client. Now, if you look at it, it's a complete application. I mean, this is a complete company that you might be running. So why would somebody take upon such challenge that he has to manage both aspects of an application? So if you look at this definition, it's very broad. Like you are typically talking about the complete application that you want to write. It's very generalized. Like there are a lot of catches in this definition. Like what does end-to-end mean? Like is it just writing code? Is it also testing your code? Is it also maintaining your application? Is it also taking care of the DevOps? So DevOps is the side where you actually take care of deployment of an application on a server. So do you take care of that aspect also? So this definition is very controversial, and it's also a debated topic of discussion, like who exactly is a full stack engineer. So this is something that we would try to demystify in the coming 30 or 40 minutes. And I'm sure like at the end of the session, you will have some clarity in on exactly tools of full stack. So why are we really talking about full stack engineering? So if you look at it, no matter how well you write your separate building parts of an application, the overhead of integration is always non-zero. What does it really mean in game language is when, so typically when you work on an application, for those who have some software engineering interning experience, you might be knowing there are people who work on the front end aspect, there are people who work on the back end aspect, and then we try to stitch together our applications so that we can see things working end to end. So if you take example of Facebook, if you don't have your backend, there would be no backend to serve data to the client, and eventually you would see nothing on that, right? So these two need to properly work in tandem. So that is why full stack engineering is really important. Now, why is full stack engineering important? Because when somebody goes full stack, it essentially means that he takes care of both the aspects. It might be a challenging task, but this is what exactly full stack engineering means. So if somebody is taking care of both the front end and the back end aspect of an application, he can visualize things more clearly. Hence, the overhead of integration. Like there are certain scenarios where I've faced in my engineering experience that I wanted certain things to be done on the back end in a certain manner, and due to some miscommunication between a front end engineer and a back end engineer, we were not on the same page, and that led to delay in the delivery of these features, or these features were not architecturally most efficient that they could be. So because of this miscommunication, because a front-end engineer was relying on a back-end engineer to provide him the data, so there was some miscommunication, and hence this overhead of integration increases exponentially. And sometimes it leads to complete revamp of the application, because if you don't communicate, things might really go bad in software engineering. So that is why a role of a full stack engineer is very important, because if he's taking care of both the aspects, in theory, overhead of integration is always non-zero. So that is why full stack engineering is really in demand right now. And the reason is if there's a single person taking care of both the aspects, so there's really very less that can go wrong. But you would see eventually in the upcoming slides that yes, there are a lot of risks that a full stack engineer needs to take, but we'll come to that in a minute. And also from a business perspective, if you see, if you employ a front-end engineer separately and a back-end engineer separately, you are essentially paying two people for the same job. But if it's possible, if you're a full-stack engineer and you have the right talent, right confidence for it, you can take care of both the aspects. And then from a business perspective, you only have to pay one person. So it's also feasible. It's like a win-win for both the employer and the employee. So that is why full-stack engineering is really being sought after. And this is just not me. I have some data to back this claim. If you look at 2020 emerging reports that was published by LinkedIn a few months ago, the full-stack engineering is currently at the top fourth position of most highly sought-after jobs in the market. So it's only next after AI, machine learning, and data science. So full-stack engineer is, I can tell you from my experience, like I've been in the industry for 4 years, and you would prefer, like I mentioned in the last point, the second point, you would prefer having one resource to take care of both the aspects rather than like paying two people to get the same job done. It's not 100% applicable every time, but most of the scenarios, most of the recruiters out there in the market, they tend to, look for full stack engineers because these people have much more command on both the aspects of front-end development and back-end. So you have the data in front of you, and in my opinion, full stack engineering will be one of the most prominent jobs in the. Now, who can you call a minimum viable full stack engineer? So first of all, it goes with any software engineering job, you should have a really strong grasp of programming fundamentals. I mean, you would be surprised. I've taken interviews for 2 years, 3 years old candidates, and they're still not able to explain me polymorphism. You know, like how OOPS works properly, like how abstraction works properly, how relatives work properly. So I mean, forget about full stack engineering. Any engineer needs to have a very strong grasp of whatever you've been taught in college. I think that should be sufficient enough for you to crack most of the programming fundamental questions that are there in the interviews. Next, you should be comfortable with JavaScript front-end development. Why I say that? Because if you go back to this slide, it clearly says skills unique to the job is React.js, Node.js, JavaScript, AngularJS, and CSS. So why JavaScript is really important? Because if you do some research, then you'll get to know about that. JavaScript is one of the most heavily language used on the planet, and it's both used in the front end and you can also now use on the back end. So you don't have to learn different languages just for working on both the aspects of a full stack engineer. He knows HTML. So if you come up with a product and you write a very good backend for it, it's very efficient, it's very fast, but you don't know how to style your product. I mean, we all gave examples of how good the UI of Facebook looks like, right? I mean, if as a full stack engineer, you don't have the capability to write pleasant looking, interactive front ends, then you would not be, successful as a full stack engineer. So this is a must-have skill that you need to learn. Also, CSS. You should be able to style your page in a good manner. It should be easy to use. It should provide most context, and it should be appealing to the user. Typically, we've seen if the engagement, so we use this metric called user engagement. So if user engagement is really low and people don't really like how you're presenting the information, then it becomes really difficult for somebody to be able to sell your product. So these are like basic minimum things you should be learning on your part to be a full stack engineer. Then you should also understand distributed systems. So this is a topic you should go back and read more about. So typically, when we have an experience of working in college projects, we don't really think about the distributed system aspect. I mean, we might have a backend server running on our own laptop, and then we SSH and connect using another laptop. So we all tend to miss the distributed systems aspects of it. But in real life, none of the applications run on a single box. To provide high availability, like a lot of people can use their application at the same time. You need to bring in the aspect of distributed systems, like your application should be highly available, it should be high redundancy, and all of those things. You should know how to design a distributed app. And then you should at least have knowledge of one primary backend language. So if you are familiar with JavaScript, then Node.js is something you can use for backend integration. And if you don't know Node.js, then a lot of us have at least some introduction onto how Java works as a backend application. So experience into each of these language can be helpful to you. And you should at least know how to use databases. You can work on any of the flavors. You can work on a SQL versus NoSQL variant. In college, we are taught RDBMS side of it. You can also look into the NoSQL variants like Cassandra, MongoDB, because a lot of data that we see in a real life is not structured. And for such use cases, you should have a look into how MongoDB fits in with all these systems. And you should know how to version your code, because this is something that we don't really learn in college. So what we have the tendency is we just keep writing code, and we don't think of a scenario where we might go wrong, where your system might crash, you might lose internet, anything can happen, right? So you should know how to use version control. I'm sure a lot of you must be contributing to open source. You might be definitely knowing how Git works, but trust me, a lot of people I have seen, they're still not able to differentiated between what is a git rebase and a git merge. So you should go back and learn about all of these things because uh, this is really important. Like if you look at this list, what this is really leading towards is you should be self-sufficient. You should be able to bring up the front end and you should be able to bring up the back end and then you should be able to stitch them together. And also you should do this in a manner that you are able to maintain your code properly. And that is where the version control side of it kicks in. So if you really look at it, it's still unrealistic for someone to have command on all of these aspects. And the reason is they're huge among themselves, right? I mean, each of these topics, though it's a bulleted list, it's an ocean of knowledge among each of these items in this list. So I would pause for a moment here and take up any questions if there are. Otherwise, we can move forward.
Yeah, Vardhan, we are getting questions from folks, but I think we can answer that these questions in our Q&A sessions.
Okay, no worries, no worries. Yeah, good. So I'll keep going.
Yeah.
Okay, so let me debunk. So by now you should have a fair understanding of who really is a full stack engineer, right? So I would also like to debunk some myths about full stack engineering because by now you might be having some clarity, but you might also be having some doubts regarding who exactly is the full stack engineer and what does his job entail, right? So if you see, if someone says full stack developer knows all type of codes, it's really wrong. What a full stack engineer has is the right attitude to be able to look into front end aspects and the back end aspects of the code. You don't really need to be an expert. From my experience, what I've seen, I've worked around into 8 or 9 different languages. From what I've seen, if you have your basics right, if you know how inheritance works, how polymorphism works, how basics of computer science works, I think you should be able, I think you should be good, right? I mean, you don't need to know the syntax of all of these languages. Trust me, as a developer, I would not expect somebody coming in for an interview to, remember the exact syntax because he might be coming in from Python, he might be coming in from Perl, from Ruby, from any background. But if he has his basics right, he's able to relate from what he's already done to what he might be getting into, I think he should be good. You don't need to know all of these languages, but you should have the right attitude of if you see a code, you should be able to relate, okay, I have some experience. Like if you see a Java code and you have an experience in Node.js, I mean, I don't think there would be a lot of difference between how the code is written. Mostly the syntax is different and few of the things of doing, data fetching and wiring up the server, that might be different, but essentially everything is the same. So you need not know all type of codes. The second most biggest myth is full stack development is a skill. No, full stack development is not a skill. It's a combination of more than one skill. So you should be good at debugging front end problems, debugging back end problems, be able to optimize your application. If you see a query is running really slow, you should be able to tune the query at the database level. So if you see, it all comes together as different skills and they then talk to each other, and then that is where a full stack engineer comes into the picture. It's not a single skill. It's a you can say you can become a full stack engineer by acquiring different skills, but definitely it's not a single skill that you can learn going through a course in 1 week or something. It's an experience that you once you start working on these kind of projects, then you learn, okay, it's an amalgamation of different skills, not definitely a single skill. Third biggest myth is full stack development is all about technical knowledge. So if we go back to the initial discussion of how a modern web app looks like, so we know it has a client. Now it also has a backend server, it has a database, but this is really a technical side of things. As a full stack engineer, if you don't really try to relate what business use case we're trying to solve, I mean, let's take an example of an e-commerce website, right? So you are a really good full stack engineer, and you wrote the front end for e-commerce application, you wrote the back end, and you brought the application live. But let's suppose in e-commerce website, what is the most common call to action? A call to action is most important thing that the user would do on that application is you would go and search for a product, right? So if you don't think of this problem from a business aspect, that you don't really provide a search box, where you can go and search in a product name and then you can filter out for that all the matching products. If you don't think it from a business perspective of what are you really trying to solve? Essentially, all the code that you write in IT solves some business use case and make some profit to the business. That is how you keep the wheel running. I mean, you don't create applications just for the sake of it or just to satiate your technical hunger. It's actually you are trying to make some money, do some profitable business. And that is why you need to also think, if I take this decision, if I, keep my data in an unstructured database, like will it cause me problems to do some joins? Like the NoSQL versions are not really known for doing the join side of data very well. So that is where you should think, if I have really structured data, will it make sense to put this data into an RDBMS solution rather than a NoSQL variant of it? So you should think of all these challenges also from a business perspective, like if you take a certain action, how will it impact your solution? So it's not all about technical knowledge, it's also about thinking it of as a product. You are writing something, each of your action would actually go and impact the performance and impact the power of the product. So you need to think of both the aspects. Now, is a full stack developer required for every project? No. Full stack developer is required when you have clear use cases that you would be needing both the front end and the back end aspects of an application. There are some projects which a very specialized full stack engineer or a very specialized back end engineer should take up. And at that point, you should think about it like, is it a job where I can handle both aspects? If not, then full stack engineer is not really good for that project. And then it differs case by case basis. If it's really backend intensive, then you might not be a right fit for that project. So these were few of the top myths about full stack engineering. So let's go to the next slide. So now it comes to the point, you should have a fair idea of what full stack engineering is, and is full stack engineering the right choice for you or not. So if you lack the ability to make competent unilateral decisions, what does this mean is, if you lack the ability to think of a solution end to end, if you're not able to think it in that direction, like if you design a product, how the look and feel of the product would look like, how the backend would get stitched together, if you lack the ability to take decisions end to end, full stack engineering might not be for you. Like I would like to mention it, like at this point, a lot of you might not be that experienced or might not be in that stage where you would be comfortable enough to answer this question. But you should just keep in mind for this. I mean, you would eventually be going into the software engineering field. And 2 or 3 years down the line, you should be asking these questions to yourself, like, is full stack engineering the right fit for me? So this is the first question that should come to your mind. And you fail to visualize the big picture of how different areas of application will work together. I've met people, I've worked along people which do not really understand the front end side of it. And I've seen the vice versa. Like I've seen people who are really good at writing beautiful UIs, but they are not really cognizant enough of how things are working in the backend. They might have a bit idea of how things work due to their experience, but they might not be able to actively collaborate and contribute to that code. So there are both the aspects of it. So you need to think, if you fail or you do not really like thinking of both the aspects of application development, then it might not be the right fit for you. And you lack the ability to single-handedly design, architect, execute, and operate an end-to-end system. So it comes from the summary of what we discussed earlier, that you need to have good solid design principles. You should be able to visualize each of the components, what component will do exactly what as their job, and you should be able to visualize them as a complete component. So trust me, no front end would work without a back end, and no back end. So back end doesn't really need to depend on front end, but if you see these things, if they don't work in tandem, you will not eventually get anything out of creating all of these applications. So you need to have the big picture of, if I take this task, how I am going to plan, organize, and go about writing the code for all of these aspects. And the last is, so what I've seen in full stack engineering, because you are also focused on the front end and the back end aspect of your application development, at times it's overwhelming, to be updated with the latest market trends. So I've seen typically in every 6 months or 12 months of whatever version or framework that you're working on, it gets outdated. And that is the pace or the cost of being a software engineer, that you always need to be on your toes so that you know what's there, what's the latest you might be using, in your application. Because, we in industry people write code at crazy pace, and if you are not incorporating the best practices, best libraries out there, you might not be considered very technically competent. So it's a lot of hard work that you need to do to be able, stay updated on the best frameworks, best design principles, best practices, both on the front end and the back end aspect of a front end development or of a full stack development. So it's a bit much. So you should have the right attitude, that you should be ever eager to learn things, and that is how you might become a good full stack engineer. So we'll conclude it here, that who exactly is a full stack engineer, right? So he understands business and customer needs well. Like he is clearly able to visualize, like if I'm writing a e-commerce website, right? I mean, the product of my focus should be that I should be able to actually search a product, and I should be able to place a product, add the product to my cart, and to check out on that product. So if you are not able to visualize all of these flows separately, then it might be a difficult task for you. So the first things that we are taught in full stack engineering boot camps or courses is you should relate to business, what problem you are trying to solve. In colleges, I was also a competitive coder back in college. So my focus was only to write the code and make it execute, right? I didn't care about how it looked like, how the readability of the code looked like, how the performance of the code looked like. I just wanted to write the code because I wanted to submit it in an online coding competition. That would serve you well when you really, when that would give you a head start in how you think about a problem and are able to come up with a solution. But if you don't think of how an impact of somebody who uses your code outside, who uses a product outside, if you lack this vision, it would be very difficult. The code that we write in college versus what we write in industry is poles apart. And that is why when people like me, they come into software, they realize, okay, I got it all wrong. I should have also focused on how I would treat a product, how I would create a product. So this is something you can start inculcating at an early stage, and definitely it would lead to good results when you go into a software engineering job. The next important thing is the role of marketing and how it coexists with engineering. So there are a lot of products in history, right? Let's talk about Skype, right? So when we compare Skype versus Zoom, so if you see, Skype has been there around for 20 years now, but Zoom came in 3-4 years, and it reached the level of success nobody would have imagined. So if you think about it, where did exactly Skype go wrong? So Skype was not able to, update itself with the best practices or best user interactions that Zoom provides or WebEx provides. So and also they were not able to sell their product properly. If a product is very difficult to use, it will be very difficult to market. So as a full stack engineer, if you don't have that level of focus, like if uh, if if you make a product very difficult to use, it will be very difficult to market and sell that product. So you should also think about like what product implications would happen if I do a product in a certain manner. So you should also think about that aspect. Third most important thing is because you would technically have the same 24 hours in a particular day, exactly like a full stack engineer or a sole backend engineer. But you being a full stack engineer, you need to take care of both the aspects in the same 24 hours. So you should really have strong project and time management. When you design these components, you should be able to estimate, okay, the front end would take 3 days, or the front end would take 1 day, and the back end would take 2 weeks. If you are not able to correlate this and if you are not able to manage your time well, then it's possible you might not get either of the back end or the front end done. So it's one of the most important challenges that people face in full stack engineering is they're not able to manage their time properly, and that also creates a risk for the entire project development. You are not able to give some concrete results at the end of your goal. So time management and project management is really important. It goes without saying you have a solid grasp of design, right? If you go in software engineering, you will be working with tech architects. And these people have lots, like years and years of experience of designing highly scalable modern web applications. Now, if you start working as a full stack engineer, now you need to think of complete solution end to end. You are no more working only on a fancy UI page, or you are no more working on a single REST API that your server is providing. You are thinking end to end. You are thinking, if I write my UI in this manner, or present my page layout in this manner, is the backend server able to provide me data in a manner that I need? So if you don't think of a design in a end-to-end scheme of things, it's very difficult for you to be as successful as a full stack engineer. So there are a lot of good design discussions, good blogs on the internet that you can refer to. But the essence is you should have solid design principles, because you are taking the job of two people separately. I mean, you are essentially combining the job of front end and a back end engineer. It might be overwhelming as it sounds, but trust me, it's a very good experience, because then you can say, okay, I own this product. I mean, I have developed it. You don't have to share the credit with other teammates. I mean, that is how I look at it. I mean, I can say proudly that, okay, I wrote this product and I authored it completely, right? So that is the pride you can have as a full stack engineer. So you really need to have good design principles to be a good full stack engineer. And you can design, architect, and implement end-to-end systems. I mean, if you have all of this right, I think there's nothing that can stop you from being a good full stack engineer. And you should have familiarity with best practices of how you would, make your page look like, how the user interaction would look like. If somebody is trying to find some data on your application, it should be easy to use. If you know if there's a benchmark in industry, if your page takes, if your given web page takes more than 200 or 300 milliseconds to load, it's called inefficient. If you really look at it, when we are in college and we are doing some projects, we don't really think about these aspects. But when you go into industry, these things matter a lot, because it's possible that there might be 5 e-commerce website and the second one works faster than you. It's possible that the customer might go to the second and get his job done. So you really need to think of what implication a certain decision that you took would end up costing the entire application. And you should know at least one single page application framework. So what exactly is a single page application? So typically back in the 90s, in 2000s, when the web server eventually came into existence, and all of these websites like Yahoo and all of these websites which have been there for long. So what you would have seen is if you did some research or you filtered for some content on the page, the entire page used to reload again. And back then, the internet speeds were not really that good. And what it ended up doing is it took 10 to 12 seconds for the entire page to reload. But essentially, what you did was you just did a button click or you just manually entered some input somewhere. So, what single page application has provided us the capability is if you are changing something on your web page, only that particular portion of the web page should get re-rendered and not the entire web page. So if you think of Facebook, right, as an application, so if there is a friend request in your list and you want to add a user, back in the time, if you did this operation of accepting someone's request, entire page used to reload because then we wouldn't have this single page application framework in existence. Now with the advent of frameworks like React, Vue.js, and Angular as well, so you can, if you select a friend request now, so it would only update that particular portion of the application and not the entire page would reload. So this is a really efficient framework that you as a full stack engineer should need to know, because if you create your own product, you should try to use the best practices available in the industry out there. So React would be a good place to start. I am a React engineer myself, and I find it. So React is a framework that was written by Facebook because they were seeing this problem that they had a huge amount of data, like billions of users, and they would not like to, reload the entire page for just one user click. So they created this framework, and a lot of good engineering companies like Airbnb, Lyft, and all of these are actually using React as their front end framework. So it's a good framework to know about. So finally, it comes down to how you look at your product as a one single unit. You should be able to debug all of these issues if your pages are really rendering slow. It could be a UI issue, or it could be a backend issue. Your queries might not be executed that fast in the database. You should be able to debug those issues. So if you think of it as a product, and then you take it as a problem. You don't think at it as a task of adding a button to your web page or adding a query in your database. It's just about a problem. You think of a problem and you think of it as a single unit. If your application is loading slow, it might be a front-end issue or a back-end issue. You being a full-stack engineer, you should be in a position that you can debug all of these issues, whether it could be a front-end or a back-end problem. So you should be able to debug all of these issues, and that would really help you become a good full stack. So I think that was pretty much it. I hope you have some context of how tricky the position of a full stack engineer could be, but it also comes with its pros and cons. Like you can boastfully say, okay, I wrote this entire application on myself, and trust me, it's a great deal of confidence because, I'm not sure how many of you want to be entrepreneurs going, 10 years down the line, but if you start having these best practices early in the stage, like trust me, even for me, like 4 years experience, I would not say sticking only to backend or sticking only to frontend is a good thing, because that way you lose the focus of the big picture. We tend to work in our own silos of backend or of frontend. You should see it as a product, as a problem that you're trying to solve, and not as a particular engineering product. And these are like, if you go through this link, I've shortened them. If you go open this link, there are 2 courses of full stack engineer that you can go through. And these are like beginner level courses, and they would help you get started with your journey in full stack engineering. So finally, I also have some references. If we go back, I have annotated this in my slides somewhere. If you want to read more about this report, so I have it there in the references link. You can also look at what other jobs are in demand right now. And this should be a self-sufficient driving factor, for you to take up a particular job. Because as an engineer, you would also like to be future safe. You might not be wanting to work in a technology, that might go redundant in next 2 to 3 years. So you can have a look at this report, and I think it should be good. I think that's pretty much from my side. We're right on time. I can take some questions if there are.
Yeah, thanks a lot, Vardhan, for such a wonderful session and throwing some light on different aspects of full stack engineering. And yep, we have a bunch of questions. I'll narrate those questions. You can answer those questions one by one.
Okay.
Yeah. So we have one question from Gaurav Jaiswal. Which full stack development frameworks are most preferable by IT industry?
So that's a debatable one, but I would tell you the top frameworks that I'm working on. So I have experience in working in Angular. Like I started my journey in Angular JS. Then, as you get some introduction into it, you should also see what others are using in the industry. What are the best practices, best frameworks others are using. Then I started reading about React, and that is how I got introduced. So when I took my next career step, I thought of exploring a role into React. So currently, I'm working as a React developer on the front end side, and I use Java, like Java 1.8. I mean, the way, it's a language we all have used back in college also. So Java is like the bread and butter of a backend, but we also use a lot of other DevOps technologies like Kubernetes, AWS, and all of this. So you should have exposure into all of these best practices. But to start, at least, I think you can look into React. That is something I prefer, but you are open to other technologies like Vue.js and Express.js. So you can look into all of those.
Okay, thanks Vadan for answering that. We have another question from Saroj Kumari. She wants to know how someone can prepare for full stack interviews, like what needs to be prepared for such interviews.
So I've appeared for quite a number of such interviews. So one thing is very important. Full stack interviews are a bit different from backend only interviews. So backend only interviews are more on the data structure and algorithm side of it, and most of the rounds are like you might have one coding interview, like just to start your rounds. Then you might have like face-to-face discussions where you might be required to do some on or like whiteboarding. But these questions are strictly around how well you choose a data structure and how good you're able to come up with an algorithm to implement the problem that you're being asked. How a full stack engineer interview differs is you would also be asked to come up with a visual aspect of things. Like you would you would be given some 50 minutes or 60 minutes of time to create with or to come up with a UI also. So that is how it differs from just a backend engineer. So you, as a backend, you might only need to write, the backend side of it. But as a full stack, you also need to create a working UI solution. So there are a lot of shortcuts that people take to create a UI application in small time. There is a topic called scaffolding. So you can read about how to scaffold an application. So a lot of our engineers in the interviews, because we have very short time and we also need to implement the features that are there in the question. So we just scaffold an application. So scaffolding is basically bootstrapping an application, and it gives you a bare minimum application to work upon. So that is how I found it different from just a backend interview. Like I started out as a backend engineer and then I transitioned to a full stack engineer. So you might be asked to code both the front end and the backend aspect in a front end in a full stack engineering.
Okay, Vadan.
I hope that question is the answer.
Yeah. So we have next question from Bhavna Chaurasia. She is saying, what is the role of distributed systems in web applications?
Okay, so it's a good question. See, what happens is none of our applications run on a single box. So a lot of people, a lot of us think about all these cloud applications, right? Like the world is moving towards cloud. But if you essentially read about it, all of this code is lying on some box, on some physical box, on some data center. Now just think about it. If you think of company like e-commerce giants like Amazon, right? So you will not say, I mean, you can access Amazon pretty much any place over the entire world, right? So, how does Amazon create an infrastructure that their application is available throughout the world? That is where the concepts of distributed system, the scalability aspect of it comes into place. So, they have this, this mechanism of doing load balancing. So essentially, they create multiple such servers which will have all the similar code running, so that even if you are in UK or in India, you are able to access this application. And that is where you say you're distributing your problem into multiple systems. Like, I mean, you can have a lot of systems running the same code, and that way you can design your application in a distributed fashion. You cannot say, right? I mean, if let's think about it, if you deploy your application on a single server and that server goes down, you cannot tell to the end customer, okay, my box went down and we're not able to access this application. So that is where they introduce things called redundancy and load distribution. And that is how you create a distributed system that provides high availability, and that application also scales very well. So you can learn more about, so there is you can learn about a theorem called CAP theorem, CAP CAP theorem, and that would give you some insight how distributed systems really work.
Uh, Thanks, Vadan, for answering that one. We have next question from Mukti Kalshekar. What qualities do you think a full stack developer must have? I guess you have covered these things in the PPT itself, but you can summarize
Yeah,
yeah.
I think it's for me, it's not even about technology, because later, like 6 months down the line, my company can tell me to work on a project that might have entirely different framework on front end or on back end. I mean, they can bring in a project which is written in Python or Go or any other UI framework. The key thing to take away here is should have the right attitude. You should have the right attitude to visualize things in a big manner. I mean, I started as a backend engineer, so I would not really care how the front end would look like back then, because I mean, it was not my job, right? I mean, it's not what I'm being asked to do. So it's about the right attitude, that you see it as a problem. You don't see it as a backend task or a front end task. You see it as a problem. You want an application that people can come and search their friends for, their families for. You just think of as an application, as a problem that you want to solve, and should have the right attitude to learn if there is a need to learn something, and also try things out. A lot of times we just go and read articles. We don't really try to do hands-on. Try something. You might fail once, you might fail twice. You should look around, go to Stack Overflow, ask one open forums like, I'm facing this issue. How can you help me debug this? So it's about the right attitude, that you should be able to think of it as a problem, not as a back-end task or a front-end task. And I think if you have the right attitude, learning is something you can do on the fly. I mean, we all are pretty smart. We all are in a good college, and I think we all learn. I mean, to be honest, like I won't remember what I learned in my second or third year, but I do remember the basics, right? I mean, I do know how the basics of computer engineering works. And that helps me to go on and adapt to any X technology, even in the future. But have the right attitude and the zeal to learn, and I think that should get you going.
Yeah, Vedant. So next to question from Rashi Jaiswal. She wants to know, can we use MVC architecture in Python-based web apps?
Yeah, I think it's not. I mean, you can. It's all up to you. I mean, if you really understand how model view controller framework really works and how you are able to abstract out your view from your model, I think it shouldn't be a problem. Language is never a constraint. It's about personally what I prefer learning and working on is something that would be future safe. I mean, I would not like to work in some technology that I know for sure is going to get redundant into 5 years or next 6 years or next 10 years. So you can take up any technology. MVC has been the bread and butter of the UI since I think I can say the .NET essentially is an MVC framework. So I started out in content development in .NET itself. But when I moved on to the single page application frameworks, I thought the framework had improved leaps and bounds. So I thought, okay, it's the right time to move to the SPA frameworks compared to the MVC frameworks. So you can still do it, but the question is, should you do it? And is there something better out there?
Okay, Vardhan. So we have a final question from this session. The question is from Akash Mondal. He is saying, I have used Flutter for mobile application development. Now Flutter framework allows to build web apps too. Is it okay to use this framework, or shall I learn React or something more popularly used frameworks?
Okay, so this question is more around can you use a same application for mobile and web app development? So it's a very debated question. What I generally tend to, so a lot of these companies like Uber and Lyft, what they're trying to do, they want to write their code once, right? So what used to happen back then, if you are a product company, and now if you want to launch a product on an Android device or an iOS device or Kindle or Windows, any X platform, earlier when they were, hybrid frameworks, like React and React Native were not there in picture, people used to write native code for all these applications. Like for iOS, you need to write in Swift. For Android, you need to create an Android application. So you need to write native code for all these applications. For Flutter, what I can say is, I mean, it's a good framework. I have done only one project in Flutter. So to answer your question, it's a matter of convenience. If you have to ship your code fast, if you only have 2 weeks to make your product go live, I will not suggest you to learn different frameworks for different form factors. I mean, you should always stick to a framework that you need to write the code once, and then you are able to ship that code or a web app or a mobile device. That's how I think, because I'm in a startup, and startups, you work on very tight deadlines. So we won't really put efforts into writing the same code twice for a web application compared to a mobile application. So it's a matter of convenience. It's your personal decision. But to ship code fast, stick to a single framework that would allow you to do web app and mobile development both. But if you have time, you can also explore a very focused web application framework, and you can use React for web app, and then you can use Flutter for mobile development. So it's a matter of convenience. There's no straight answer to that.
Okay, Vardhan. I think we have covered all the questions asked by the attendees, and yep, that's all for the Q&A part as well. So before ending this session, I would like to thank you, Vardhan, for taking your valuable time and giving this such a wonderful session on full stack development. And I really
Yeah.
hope this will help our attendees to uh, know about like what are the different aspects of full stack engineering and how they can make their career into it. So yeah, again, thanks really a lot, Vardhan. Thanks.
Cool, man. It has been a good, because I know I come from same background and I had lots of questions when I graduated from college. So I'm happy to contribute back. And if you have any questions, you can reach out. I'll be happy to help.
All right. Thanks,
Cool.
Vardhan. Take
Thanks.
care.